Hey, you're welcome here. And I am Neor from CloudMQP, an experienced RabbitMQ and LiveMQ hosting team. And we made this video to, first of all, help you understand the big issues around using synchronous HTTP in microservices. And secondly, to explore how switching to asynchronous message queuing can make things easier for you. Stay with me. To begin, let's see how synchronous HTTP introduces tight coupling between the services in the microservice architecture. We will take the case of a retail store application built the microservice way. The retail store application will have the following services: an order processing service that handles the order details and initiates subsequent actions, a payment processing service that processes the payments for an order, a shipment service that processes the shipment to the customer, and a notification service that sends email notifications to the customer providing updates on the status of an order. In our HTTP-based microservice, when an order is processed by the order processing service, it triggers a chain of actions: processing payments, processing shipments, and sending email notifications, for example. Hence, the completion of an order is dependent on all these actions. This is true because of HTTP synchronous request response nature. The order processing service sends requests to the payment, shipments, and notification services and waits for their immediate responses. This tight coupling between the order processing service and the other three services results in a few problems. For example, inability to isolate faults. And what this means is a fault or failure in one service can have a cascading effect on the order processing service. This can halt the entire order processing flow. We'll also have issues with long response time. And this means that delays in payments, shipments, or the notification service will directly impact order processing. Lastly, we're going to have issues with inflexibility in introducing changes. Introducing a new microservice will require modifications and redeployments of the order processing service to consume the features offered by the new microservice. As mentioned earlier, the drawbacks above stem from the request response nature of the HTTP, which assumes that every request triggers an action that must be completed immediately, leading to synchronous actions. In reality, however, not all actions require immediate completion. Actions like that can be executed at a later time. For example, in our case, while it makes sense for the order processing service to wait for a response from the payment service, it does not really need to wait for responses from the shipments and notification services to continue with the order processing flow. The shipment and notification actions could be executed at a later time. All right, I know we've said a lot so far, so let's do a quick recap before we proceed. Now, even if you don't remember anything we've said so far, just remember this one thing. HTTP's default synchronous request response style has the potential to introduce tight coupling in a microservice setup. Now, we're not dismissing the fact that there are certain scenarios where the synchronous HTTP-based communication pattern will be desirable. For example, in our case, payment processing is necessary to consider an order complete. In that scenario, it is more ideal to implement a synchronous communication between the order processing service and the payment processing service. On the other hand, shipment processing and notification actions do not need to be completed before an order could be considered complete. As a result, it makes more sense to decouple these actions from the order processing flow. In a scenario like this, using a message queue between the services will be more advantageous. Again, let me show you how. With a message queue, when an order is processed by the order processing service, it can enqueue a message indicating the need for notification and shipment processing. Instead of directly invoking those services and waiting for their responses, the order processing service can continue its execution independently. The notification and shipment services can then also subscribe to this queue and process the message. Here, the message queue acts as an intermediary holding the message until those services are ready to process it. This asynchronous approach allows services to operate independently, breaking the tight coupling that exists in synchronous HTTP-based communication. And this approach has some benefits. Fault isolation. Because the direct dependency between the services has been eliminated, if a service encounters a fault, the other processing service would continue processing requests independently. Reduced response time. With message queuing, the other processing service can asynchronously process requests without waiting for immediate responses from the other services, reducing the overall response time. Lastly, flexibility in change introductions. In our use case, if a new service, such as an inventory service, is introduced, all we need to do is bind it to the message queue and have it consume messages. We don't need to update any of the existing services at all. In addition to the tight coupling issues we've discussed so far, using HTTP as a communication pattern in microservices also requires third-party load balancing and service discovery solutions, which could actually be simplified with a message queue. So far, we've only shown the architecture of our retail store application to only have one instance of each service running. In more realistic scenarios, you're more likely to have multiple instances of each service running. Having multiple instances of the other processing service, for example, creates the need for a mechanism to distribute requests among the instances. This problem is commonly solved with a load balancer. But beyond load balancing, like most modern cloud-native applications, our retail store application will run in a containerized or virtualized environment. But here is the catch. Virtual machines and containers could have dynamic IP addresses. This implies having instances of the other processing service with dynamic addresses. Furthermore, the number of available instances in a cluster could change. For example, you could scale up or down, or some instances could fail to start for whatever reason. In essence, before our load balancer could evenly distribute requests among available service instances, it has to, first of all, know what service instances are available and where to find them. More technically, we will need a service discovery mechanism. Again, one common way to solve this problem is to use a service registry. Remember, you will need to implement this load balancing and service discovery mechanism for each service that we want to run more than one instance of at a given time. For example, if we decide to run multiple instances of the notification service, then there has to be some load balancing and service discovery between the other processing service and the notification service. Even though we've talked about how HTTP-based microservices introduce the need for load balancing and service discovery like it's a bad thing, just to be clear, we are not invalidating these approaches. We're just saying they require more work that could be avoided if we use message queues. On load balancing, when adopting the message queue-based microservice architecture, the need for explicit load balancing using a third party is also simplified. Load balancing becomes an inherent part of the architecture. When multiple consumers are bound to the message queue, in our case, multiple other processing services, the queue will distribute messages among these instances as per your configuration. If you've made it this far, then well done to you. We've said so much about message queuing so far. If at this point you're interested but not sure how to get started, at Cloud MQP, we got you. We have a collection of resources for you on our message queuing landing page. I will leave a link to that in the description of this video. We also have the blog version of this video, which is probably more detailed. And if you enjoyed this video, don't forget to hit the like button and subscribe as well, just so you get notified when we put out new videos. See ya. Bye.